My name is Ivan Sharamok. I'm a principal solutions architect for Tigera. Tigera is a company who created and maintains open source project Calico product that is known for networking security and in the commercial versions of it for observability for Kubernetes. So in this talk, I will talk a little bit about why compliance is necessary, how to achieve compliance, and why traditional compliance standards do not, or techniques do not really work for containerized applications, specifically to Kubernetes platform, and how we address it using Calico. The most of the talk is kind of like generic, not related. If I have any time left in the end, I can show you to kind of like map out some information that I'm going to be sharing today to what it looks like in Calico and how we do things. But it doesn't mean that's like the only way to do that. So a few words, Calico. Does anyone know what Calico is? Can you raise your hands? Oh, okay, cool. Anyone uses commercial version of Calico? Oh, looks like sound came up. Okay, sounds good. So the numbers I'm showing here, this is in relation to kind of like overall who uses Calico, at least people who we know of. There is a lot of Kubernetes environments that are built where we don't have visibility into, so they don't share the numbers with us. But as a ballpark for us, it's the most adopted CNI for Kubernetes platform. CNI stands for Container Networking Interface for Kubernetes. Closer to the topic in terms of compliance, you can see some of the acronyms in there referring to compliance standards like PCI, SOC. Usually you would hear something SOC 2, FedRAMP, HIPAA, GDPR that you all probably familiar with. There is a bunch of different compliance standards, and each compliance standard has a set of controls that you need to implement. And then once you implement those controls, you need to prove that those controls implemented correctly when the audit comes, that they can verify that everything is up to that compliance standard. Why it's necessary? Typically, if you are in business where there is some regulation that is mandated, typically by the government or some kind of authority, but usually it's the government in one way or another. They can work through a proxy, but usually the kind of like enforcement comes from that part. And once, if you're, let's say, handle financial information, there is credit card data in there. In healthcare industry, there is a lot of your health information that is stored somewhere, and that needs to be secured in one way or another, or whenever it moves around the systems, that needs to be done in a secure way. So you would see any compromises that happen. A lot of governments nowadays implemented the policies where someone gets compromised, you need to kind of like disclose that compromise happened, what was compromised, what we are doing about that. All of that comes from the regulating authorities kind of building those laws and imposing that like at the level of like implementing the recommendations that become in laws, and you have to comply with those. And there are two aspects of compliance. There is enforcement, that's enforcement of controls that I was talking about, that each compliance standard has different types of controls that you need to enforce. And once you enforce that in your system, over time there is an auditor that shows up that needs to do audit to where you need to demonstrate that is working correctly. Some of the requirements, so a lot of this talk is going to be related to Kubernetes because Calico kind of like the native component of Kubernetes platform. And so I'm coming from the perspective of overall the Kubernetes platform, running the applications in there, the networking aspect of it, how to implement the compliance controls for that platform, since it's quite different to traditional application deployments when you use some sort of bare metals, static VMs that have information that doesn't mutate that often. So some of the examples of compliance is that your Kubernetes environment itself, when you build it, it needs to be compliant with certain standards. If you've heard, there is CIS or CIS benchmarks. That's one of the examples that works for kind of analyzing your Kubernetes nodes, whether they are compliant with certain standards or whether you have some configuration in there that needs to be adjusted so that you can prove your compliance. Often, what we see, especially at the smaller companies, that Kubernetes platform by itself is flexible enough that it can allow you to run a bunch of different types of applications. You can build even environments inside of the same one cluster. You can kind of segment it through the concept of labels into different environments for the end users. I mean, like for developers, they can use part of it as a QA, for QA deployments, some for integration for development, and well, typically you don't share a production platform, but in some rare cases you can see even that. And so you need to do some, to implement compliance controls to make sure that your applications do not mix, and you can prove that they cannot kind of like cross the logical boundaries of those different QA environment or dev environment and go talk to each other. That also applies to having something like multi-tenancy when you can have, and tenant is kind of like a loose term, if you will, for when used with Kubernetes, because it can represent an application or it can represent a team. So it depends what is typically meant by tenant in there. But in general, when you have a multi-tenancy that you build, you need to prove that tenants are isolated and they cannot kind of talk to each other. Any sensitive data, like PII, personally identifiable information, that is something for financial sector, like especially companies that handle credit card transactions, they would work with the data, or anyone who allows, who does the charging through their platform. They would handle that data because they take information, you put the credit card number in the on the website when you're trying to go and pay for something. So as that data moves through the systems, whatever components handle that, they need to comply with certain standards. So why traditional methods do not really work for Kubernetes is because of the dynamic nature of Kubernetes platform. Anything you deployed in the form of your application stack can be comprised of multiple services. And those services can have from 1 to X number of pods deployed. So it can be a typically deployment with a replica set in there. And so that means that the IPs that traditional systems usually rely on to kind of prove compliance, to collect that information and then later use in the compliance reports, that information cannot be relied on to prove that. Also, some of the controls defined in traditional firewalls, as an example, can be using FQDNs. For Kubernetes, that is not that simple when you're saying, can certain application be allowed to go and talk to some FQDN? Maybe there is some SaaS service that you're consuming, the application consumes, or you talk into your databases in your network just outside of Kubernetes cluster that is exposed through some sort of domain name. How do you prove that only your application was able to use that? So that becomes difficult in Kubernetes. And specifically, like some of the reasons for that is that your cluster, when you build your Kubernetes cluster, nowadays a lot of platform teams, when they build the cluster, they choose to use a private network range. So it's a private set of IPs that is used for the pods. You can still use the routable IPs, and especially, I talked to a number of people in this conference. A lot of people seems to be using something like EKS or AKS, EKS for AWS service, AKS for Azure service. And so those platforms allow you to configure the range for the pods or the network range that is from the VPC, meaning that it's routable IPs within that VPC. But a lot of companies, especially when building larger clusters, bigger platforms, they tend to use the private ranges. And the reason for that is that The VPC that you use in the example of kind of like this managed Kubernetes services, EKS, the VPC that you use has a limited number of IPs in there. Usually it's like /16, but they are shared between the pods and the VMs themselves and whatever else you deploy in there. Any service you deploy within that VPC would take an IP address. So at a certain point, you cannot scale more just because you hit the limit. And so that's why a lot of platform teams, whenever they decide that I want to be able to scale to kind of like factor in the future scale in there, so they choose to use the private CIDR range for Kubernetes platform so that the VPC IPs would be just used by the AWS services. And whenever time comes to kind of prove compliance, and typically it's done on some scheduled basis. I don't know if there are daily compliance standards, but there are definitely like quarterly, yearly compliance standards when you have to kind of run those reports, demonstrate that you are compliant with that standard. If you are not, usually you get some sort of warning from the regulating authority saying you have X number of days, typically like 30, 60 days, depends on the standard itself, that you need bring everything into compliance. If you are not, then you get penalties, and kind of like those penalties keep increasing until you get something like ceased and desist a letter, meaning that you cannot operate, your business cannot operate anymore until you fix all those issues. And as an example, PCI, one of the standards for credit card, for companies who handle credit card financial transactions. So if the company handles over 6 million transactions a year, they have to do the PCI compliance standard in order to operate in the, I'm from US, so that's in the US, that's the rule. Another requirement is that when you deploy your application stack, some of the components, they touch this, an example for PCI, they touch sensitive data, so they have to comply with the standard. Some of the components, they do not have to. So it's kind of like mix and match. The easiest way to kind of implement everything and saying, oh, it's all part of my PCI standard, or whatever compliance you're using in there. But the power of Kubernetes comes from the fact that you can deploy a bunch of different apps, and you can then have them live in that platform. They kind of move around freely within the confines of Kubernetes boundaries, and you don't have to kind of like go and manage those individually. But when you do that, that means they all co-hosting and kind of like co-sharing the resources. And if you don't have the proper controls set up that they cannot kind of like jump and talk to other services from other applications, you are breaching your compliance standards, as an example in there. So microsegmentation is one of the ways to ensure that your applications can only talk to the services, to the services within the application stack or like within the Kubernetes cluster that they only allow to talk to, and everything else should not be allowed. So that's something that is difficult to achieve with the traditional firewalls, just because if I take the example even of the routable IPs, when you create your Kubernetes cluster and give it routable IPs that you can route through the firewalls, those IPs change frequently. Something happened to your pod, one of the pods of your application service. It churned, meaning it restarted. Once it restarted, it gets a new IP. It still carries the same function and it operates in the same way, but now it's a different IP. So like in your firewall that is kind of built to use IP as an identity, it becomes difficult to implement any policies in there because they need to be changing, kind of like following what pods are doing, the life cycle of the pod. So how Calico addresses these issues? We provide vulnerability management, and yeah, just to be clear, for those who are using Calico or know what Calico is, some of the stuff I'm talking about here related to Calico as a whole, not just the open source, because we have the open source piece and then we have commercial pieces. So some of the stuff like vulnerability management, that's a part of the commercial piece. So we provide vulnerability management where we can scan images, build something called software bill of materials, or for short SBOM, that gives you an inventory of all the packages and all the binaries in your container images. We map that, we run the scan, we get that SBOM, then we map everything that we found against the CVEs. That's common vulnerabilities and what the E stands for, exposures. So it's a database of vulnerabilities that we take and kind of like map all of that so that we give you the inventory of what you have in the images mapped against the known vulnerabilities. And you can go and kind of see what level of exposure at that level you would have if you deploy those images in your cluster. But we map that with the admission controller, and we also map where you run images in your clusters. You can have many different clusters. If I have time in the end, I can show you like quick peek into that. If not, we have a booth outside. You can stop by and I can show you how that works. We provide the workload segmentation through Calico policies. In the commercial products, we also offer the tools where we can provide you policy recommendations. So if you don't know how to build those policies, we just look at the traffic. Since we sit at the networking layer in the Kubernetes cluster, we see all the traffic in there. So we can recommend you policies based on actual traffic that we see. We provide encryption for data in motion. We also we provide the flexibility with the policies that you can build them according to whatever compliance standard you need to follow. We have the reporting tools where the data that we collect, we provide some of the out-of-the-box reports, but you're not bound to those because you can take the data and you can run kind of like build that into whatever reports you would need. And the audit logs for the audit trail. So whatever policies you deploy, who changed, when that policy was changed or deployed, and what changes were in there. We have all that audit log to present to the auditors. And so to kind of expand on some of this, so for vulnerability management, what we mean by that is that we provide the image scanner, and there are a few different flavors of how we do the scanning, but that's one of the pieces to kind of like scan what you have, what inventory of binaries, packages you have in your images, map that to CVEs. We have admission controller that bundles with that uses that information to decide, you deploy a policy for admission controller to decide what is allowed to be deployed in the cluster. If the image doesn't pass the scan, at what level? Did it pass? Did it get a warning? Did it get a fail result? And what the threshold to get that result? And then with admission controller policies, you can decide what to do with that. Whether to fail, like prevent the deployment of the image altogether. And we give you a runtime view where we take the images that you scanned. You not necessarily may have deployed those to your cluster. Because we have different ways how you can do the scanning. You can scan against your registry, image registry, so you can just point the scanner there and say, hey, can I get the scan for all the images I have in there? But maybe only a handful of those are running in your cluster. So we provide the runtime view where we take the images that you scanned and we show you where they're running in your cluster. And we show in that context, we show the information, what CVEs, what packages you have in there and what CVEs you have in there. So that you can see your exposure to certain vulnerabilities in there. Then one of the kind of like, I would say it's a subtype of microsegmentation, but we separate that egress controls as its own way of securing your applications. Because when you run application in Kubernetes, it does not necessarily mean that it will only talk to other components running in Kubernetes. Quite often, you need to go and talk to the services that were not migrated to Kubernetes, or services that cannot be migrated into the platform. So you talk to them by IPs or FQDNs, and so you need to secure those communications. Another way to talk to the services outside, and especially within your network, is to like talking to the database, but you have to traverse the firewall as the part of the compliance that you need to comply with, or as a part of the rules that security team set up for all applications. With, again, mapping this back to the what I was talking about, like private IPs for the pods, that becomes impossible, or not impossible, but nearly impossible, just because the IP is not known outside of Kubernetes cluster, and if once the pod says, like, I need to go to talk to the database that lives in your network outside of the Kubernetes, once it gets outside, that IP is no longer pod's IP. So you cannot create a policy in your firewall saying, like, use this IP for the pod to allow the access to the database. Usually that IP gets NATed to the IP of the node where the pod at that time is. And so then it can get out and kind of like traverse your network, and the packet can get back. But the problem with that is that in the firewall, at that point, you can only program the IP of the node. And if your nodes are big enough, you might have in there hundreds or thousands of pods running, and so which pod was going and talking to what, that becomes difficult to tell. And for compliance, that also doesn't fly, because you cannot prove that that communication was only from what is allowed to go and talk to the service outside of Kubernetes. So we provide something called egress gateway, where you can assign a static IP, known IP, and you can map it to a namespace or down to a specific pod, because it uses the same concept of labels and kind of like using labels to map which pods will carry that IP outside of Kubernetes cluster. And so in that way, you get in the stable IP, so the pod restarts, it changes its IP internally inside of Kubernetes cluster, but the traffic leaving Kubernetes cluster still carries the same IP that you define in there. It's called egress gateway. For microsegmentation, the policies, they are declarative as pretty much everything else in Kubernetes. So you build your YAML or JSON, whatever you prefer to work with. You deploy that as a part of your application stack using CI/CD pipelines. That's what majority of our customers do. This screenshot, it's an actual screenshot from a commercial product where we can show you how the policies visualized, how you deploy those policies. And there is some governance aspect of it, and there is kind of like hierarchical nature of how you build policies. You can map who can manage from the different teams, what kind of policies in there. But it's all with the concept that policies are applied in a dynamic nature, following the concepts of Kubernetes, because the way they work, you run a kubeapply command to apply any object like a deployment or a policy YAML to the cluster. Kubernetes ingests that information, puts it in its own store. Its CD database is used for Kubernetes as the storage. And then whenever pod gets created and the labels on the policy, in policy selector, there is a field policy selector in there where you specify the labels where that policy should be applied. So when the pod gets created, the CNI supplies programs the data plane on each node for the policies for that pod. So the policies are not deployed automatically across all of your nodes in the cluster, because if you have a very large cluster, that would be a huge undertaking. It kind of follows the pods, where the pods are going. So if the pod is restarting and moving to another node, the policy information, the policy rules get turned down on that node if there are no other pods that match that label, and recreated on another node. So it's kind of like a following the life cycle of the pod. And we provide the topographical view of all the communications in the cluster. So whichever pod service is talking to what in the cluster, we graph that, we put it into the graph. And we can also, so with Calico policies, you can also apply that not only to the apps running in Kubernetes, you can also go beyond that. You can apply Calico policies to the hosts. So not only protecting the ports of pods, but also Kubernetes hosts, you can even go beyond that. You can install Calico as an agent on non-Kubernetes hosts, like VMs, bare metals, and pair that with your Kubernetes environment and have Calico program policies on both ends. You can do it from one end, just in Kubernetes, and control egress to the outside services running on VMs or bare metals. There is an object in Calico called host endpoint. That's the way to create that, and then you can control egress traffic in that way. But if you want to secure connection on both ends, and you need it for, on the other end, that's going to be VM or bare metal, you can install Calico agent on that VM, and you will be able to program policy on both ends. For data in transit, we use a tool nowadays it's a Linux kernel module called WireGuard to do the encryption. There are several different ways how encryption is done for Kubernetes workloads in general. There is IPsec, OpenVPN, WireGuard. It's a module that I think it was added to the kernel probably 2 years ago or something like that. It's not that long time ago. Like IPsec is very old technology, so that's been for a while in Linux. WireGuard is kind of newish. There is another way how to secure communications through TLS at the service level. So if some of you used or heard of Service Mesh, that's a technology or stack that can be installed in Kubernetes, which provides you with some like visibility in how services talk to each other, and it provides the encryption through TLS. TLS implemented at the application layer. So it's higher up in the stack. If you're familiar with OSI model, so application layer, it means layer 7 versus WireGuard works at layer 3. Some differences in there that for layer 7, to use TLS certificates, you need something called certificate authority. If you are all on the web applications, application development side, you typically don't deal with that. That's set up by the platform teams or security teams. Typically, they kind of set up a certificate authority and manage who gets which certificate. That's what service meshes do, kind of like automated that for Kubernetes. But that operates at the application layer, which means only your application payload is secured. And also it has kind of like layers, adds more to how it does the encryption, and WireGuard works at layer 3, so everything from layer 3 up gets encrypted, so you won't see even ports who's talking to whom. For compliance reporting, I kind of mentioned that we have the capability to generate compliance reports, and here's a list of some of them, like network access or inventory, CIS benchmarks. But you're not just bound to those, because you can take our data and generate your reports yourselves, depending on what standard you need to prove compliance for, and how you want to see that data. Some of the key takeaways for the compliance. You need to implement security policies in order to prove in order to enforce that your application components can only talk to what they need to talk, what is allowed, and especially if it's like PCI or if it's SOC 2, anything related on the networking level where the communication needs to be happen, and it needs to happen only with specific, only allowed endpoints. You need to implement network policies for that. You need to be able to automate all of this, because you will deploy, or you are deploying, a lot of different applications onto the Kubernetes platform. And when there is a lot of them, there is no way, or you won't have enough time to go and kind of like manually do everything. Usually you would tie that up into CI/CD pipeline, and ideally, CI/CD tool would be the only tool that is allowed to deploy something at least into production. In a lower level, there are some, of course, people can get around those deployments, and sometimes they need to. But for production, the standard or the recommended practice is that you set up CI/CD pipeline, and only through that pipeline you can deploy anything that you need to touch in the production clusters. You only go through that route. Yeah, the last bit in here, you need the ability to be able to generate reports on demand whenever you need that. So one of the challenges, for instance, for auditors is that they can come and investigate, kind of like look at your platform, run through their checklist for whatever compliance standard needs to be followed. But then whenever they do verification, that only in that point in time, they can say, okay, you're compliant with this. But let's say next day you have a rollout of a new application, or the same application just redesigned, and so that compliance is now broken because you need to go and kind of review everything again and make sure that you're compliant. So you need some tools to be able to build those reports, compliance reports, to see whether you're compliant or not. One of our customers used our commercial product for the in financial fintech SaaS vendor who built the fintech platform. And for fintech, or for a lot of SaaS platforms, we have Calico Cloud as our SaaS offering. We as well have to be compliant with the SOC 2 standard. So they used us to build their platform and to prove the compliance, SOC 2 compliance. We have a case study on this, Mulligan Funding. That's the company who built it with us. So they've used our product to achieve that compliance, and you can kind of go take a look at what they use specifically, what they called out from the product that helped them to achieve that. Why Calico can be useful to prove compliance, to kind of implement compliance controls and prove the compliance. It removes the security blockers. You can easily create policies. And I don't know how much time I have, but I think I will be able to show. Yes, it looks like I can show some of the tools that we have. And what I'm talking about is removing the security blocker, where you can craft the policies without even knowing how to build them, without going into complicated details of how to build the rules, who needs to talk to whom. We can just take a look at the traffic and we can offer you policies, and you can deploy them in a manner where you can test them first and then come in and say, like, okay, policy seems to be doing what it's supposed to, let me enforce that policy. The enforcement bit of it is very fast. It applies in milliseconds, comparing to some of the anecdotal stories that I heard from the customers. It takes them weeks to implement a change in a policy. I don't know why that happens, but usually that's because the change has to be requested through a ticketing system. Then there is a security team that is always overloaded and kind of like works through a queue of different requests. And by the time they get to that request to implement something, the change, like in firewalls, it can take them days to get there. And to demonstrate the proof, to kind of like build everything into the report. So I believe this is my last slide, so I can actually show you what kind of data we collect and as an example, I'll use Calico Cloud just because it's an easy setup for me to show the clusters. You can see I have a bunch of different clusters connected to the platform, so you can assemble like whatever Kubernetes version or flavor you're using. You can connect it to Calico management plane, and from there you'll have all these tools. So what we shown here, or what we do, and probably could be useful to many of you, is the ability for us to map what is running in your cluster, how those applications and their components, how they talk to each other. So at the higher level right here, I'm showing you view from the namespace point of view. Actually, let me switch to a different screen so that I can also run a test script to generate some traffic. Yeah, so at the high level, we map info about all the communications and we show you from the namespace point of view, but you can double click into any of these namespaces and get the view from the inside. So what are the deployments, what are the components that are running inside? Everything that you see in here, you see at the bottom there are different tabs in here. The flow logs, that's what we use to build this graph, and that's what we use when I'm referring to like how you would prove the compliance, how we build the reports. That's the information that we use. There is a lot of data in here, so if I open up one of those flow logs, you would see there is your typical 5-tuple for network flow log, but it's married with the Kubernetes context. So you have the information about source, namespace, the name of your deployment or service, same for the destination, source labels, destination labels. You have the information about the decision that was made, that traffic was allowed, or which policies were evaluated for that communication. So all this information gets compiled because for every request that's happening in the system, we collect that info, we build flow logs into that, and so you have historical data. Whenever the compliance audit comes up, you run the reports against those flow logs, you collect the data, and then you can present like, here's what happened at that time, point in time. Here's what I had. So you can see we also can collect like the amount of data moving in and out. There is more info for like all the in-cluster communication stuff. So if I select something like connection to the card service here, and show you details in here, so you can see, we can see exactly which binary run inside of the container, which ports are used, or process ID was used, the TCP level metrics. If you have SREs that have to monitor some business critical services, this is typically TCP level metrics. That's what they are interested in, to make sure if service starts kind of like latency starts increasing, and they need to go and look at that. All of this data, you can generate, set up your alerts for whatever you need, and you kind of like can watch this data or build the alerts that will use this data to generate an alert in whenever something happens based on the query that you select for that or set up for that alert. So when I ran my, just a few moments ago, when I ran my script, I generated a bunch of connections. So now you can see some of the connections in here highlighted in red that represent that communication happened, but it was denied by something. So we give you the breakdown of which policies. You can see all that information that I showed you in the log. We kind of put it into some of that info that is used quite often. We put it into this flyout panel that tells you what happened, and we also can highlight the policies that actually did the deny. So you can see exactly when deny happened, communication didn't work. You can troubleshoot this stuff really easily. Within the policies, whenever you deploy them, so if you're using Calic open source, again, this is part of the commercial, all the visualization tools. You would deal or kind of like manage everything through kubectl command. Everything you deal through the CLI commands. In the commercial, you would see everything that you deployed in the cluster. And we also added each of these columns that you see, like security, platform, application, default. Those are called policy tiers. So you can deploy policies into those policy tiers depending on what policy is supposed to do. And you can map those tiers in different ways. Like one of the ways is to like team function. So that's exactly how I set it up for this example. You can have like security team come in and configure their policies in security tier. And they would typically set up some guardrails, overall like overarching guardrails for the cluster. Then platform team would come in and configure the policies only for the components that they are managing. And in my example, the developers would come in and deploy the policy in application tier. And all of this to Kubernetes look like native Kubernetes objects, which means you take standard Kubernetes RBAC and you can create governance. You can decide which teams have access to what tiers and what level of access. You can make some policies read-only, like that's how typically I do that, saying for developers, they have full access to application tier and maybe only to the namespaces they need to work with. Everything else, just make it read-only for them so that they can see the policies in there, and because they can click and kind of like whoever wants to look and understand how traffic goes through those policies, but they would not be able to come and kind of mess with those and do something that they don't intend to do. Because some of these policies, you can see here it says global, and here it says hipster shop. So hipster shop is one of my namespaces for the demo app. Global is that represents a scope. So there are namespace policy, and then there are global policies. Global policies don't care about namespace. You create that, and it applies across everything. You can still refine the policy scope for global policies with the label selectors, but by default, if you don't specify a selector, that means you apply it everywhere. So those are, if you don't know what you're doing, those are kind of dangerous policies. That's why I'm saying you leverage RBAC to set up governance, who has access to what, because you can limit and say, hey, developers, you can only deploy namespace policies. Or even going further, you can say, you can only deploy namespace staged policies. So that's what I'm about to show, one of those examples. I mentioned a couple of times that we have the ability to recommend you a policy. So in here, you can say, hey, Calico, for the last 15 minutes, can you take a look into one of the namespaces and recommend me a policy for that namespace? And Calico goes, looks at the traffic that happened for the last 15 minutes and says, oh, here's the traffic that I'm seeing. And from here, you can go and download this as YAML, or you can do one of these actions. You can preview this, stage it, or enforce it. I'll show you a preview on an existing policy, just because I already have enough traffic in there. For staging, that's an ability for you to deploy the policy in a permissive mode. So you deploy that policy, and you would see how traffic goes through it. But if that policy all of a sudden starts denying traffic, it doesn't showing you that it would deny traffic. It doesn't actually deny anything. It just shows you for the testing purpose. Here's what would happen if you were to enforce that policy. And I'll show you this as an example. Because everything is declarative, I can build and tear it down within seconds. So that's kind of what I'm going to do. I'm going to remove all these policies and apply one of the stage policies to show you the kind of the effect of this. So right now, I don't have any policies deployed. And if I run my test connection script, which runs connectivity tests between services within namespaces, then across namespaces, I'm going hitting some a few external FQDNs like Twilio, and I think I hit apple.com or google.com, something like that. I also run a few ICMP packets to Google DNS and level 3 DNS just from a few different locations in there to show what happens behind the scenes. So you can see all these connections right now. I'm getting the response in there either 200 or 301, which means it passed. I got the response back. Everything goes through. So now, when you kind of look into the Kubernetes security interest group and their recommendation, they're saying you need to deploy default deny policy when you build in your security posture for the applications. And from there, like once you deploy, as you deploy default deny, it cuts out all the access for the apps. And then you start deploying policies that only allow the communications that need to be allowed. So now I'm going to deploy that default deny. So you'll see that landing here in the default tier. So typically default deny means it should be the last policy within the certain scope. Either if you're deploying default deny for the namespace, it's last policy in the namespace. And by last, I mean like the order of evaluation. Because you want to go traverse the policies that allow in the traffic, and then last one is going to be default deny. That's for the traffic that is not allowed. So you can see traffic starts hitting it. You can see this label staged, indicating that this is a permissive policy. So if I rerun my test connection, you'll see that nothing is broken, nothing is denied. And that's kind of the purpose of these stage policies, that you can deploy them, you can test them, and once you're happy with what they do, then you can come and enforce that. A lot of our customers use stage policies in the lower level environments, In production, it's always enforced because there everything is tested. You want that to be enforced. In the lower level environments, they want this to be staged so that they can see that whenever something is misconfigured, the traffic hits it and it highlights and shows you that, but you don't stop developers from doing their work. If they forgot something and they deployed the application and it's blocked, they cannot do work. They need to figure out what to do with the policies. This allows them to see that something is misconfigured and they can go figure it out, but that doesn't stop them from continuing to work. So you can see all the traffic still went through. So now if I deploy back my policies that I just removed, and these are enforcing policies. So in here you'll see, you can kind of say by policy type in here. When it says either network policy or global network policy, that means it's an enforcing policy. If you see a keyword staged as a part of that name, then you know that's your stage policy. So you can see I'm adding this back, and so what you would see in a moment that traffic that is currently showing up on this default policy, and we kind of refresh this every, I think, like 10 or 15 seconds, you'll see that over time, over next 30 seconds or maybe a minute, this traffic will start coming down and eventually drop off, and that's your indication typically that, okay, your preceding policy do the right filtering for all your application services talking to each other, and that's why it's nothing hidden my stage default deny anymore. That's your indication that your filtering is done correctly. Yeah, you can see this is coming down right now, and in a few moments it will drop off. But also, I mentioned the vulnerability management as one of the aspects in the platform. So image assurance, that's that part that shows the vulnerability management. I'm running this through my phone internet, so it's kind of slow to get the data. Okay. So I got it. So you can see there is a huge list of images. There is 932 entries. This is a shared cluster that my team uses. There is a bunch of different clusters, a bunch of different images. But an example, if I click on the image, it shows you all the packages that it found in this image, all the libraries. So this one happens to be quite big. And you can see some of the packages, they have a critical level of severity for vulnerabilities. CVSS, that's the score for CVEs, for those vulnerabilities. You can kind of like go and read what this is about, but what's nice about all of this, there is a view where we show you running images. So if I take that example of Hipster Shop, and take one of the images running in that cluster, so you can see these are all the clusters where it's running, and these are the namespaces where those images are running. And here is the vulnerabilities and those packages and vulnerabilities inside of them. So that's kind of the quick example of what we can do at a high level. There is a lot more to this, but so all the data that I was showing within the flow logs, you can kind of slice and dice and shape that into your reports for compliance, whatever compliance standards you need to follow, and build your continuous compliance using that. I believe that's it, and I'm out of time, right? Okay, thank you.